Brody Precision Tech Tuesday. Today we are going to do kind of an overview and a review on LON Spyders. The LON Spyder is a twisted pair controller. It's sort of like seeing less and less of them being used because of the advent of the Ethernet controllers, and most of our contractors are using the backnet flavor of the Spyder, but we were asked to do a review on the LON Spyder for years now. You know that there's thousands of these networks that are out there, and thousands of these systems that can be added to or upgraded. So we were going to cover some of the basics when it comes to this particular controller and how we interface to them. Wanted to cover things like uploading and downloading, and we were going to review the Spyder tool and the overview of the Spyder operation, and maybe we'll talk a little bit first about the basic LON trunk best practices. That being said, for the LonWorks bus wiring guidelines, the controllers, every device has what's called a free topography transceiver built into it. Transceiver, it's a transmitter and a receiver. And each of these devices has a unique neuron ID associated with it. That's how a LON network separates one controller from another, along with network parameters. But to back up a little bit, the free topography transceiver supports a polarity insensitive wiring. So that means we don't care, like a backnet network has a positive and a negative. A LON network, extremely resilient, doesn't care which wire you put under which terminal. There are multiple bus topographies, including T-tap, star, loop. Mixed wiring topographies are all supported by this architecture. I do not see very often the star and the loop and the T-tap. Occasionally we see T-taps, but then you're starting to get into a more complicated topography where you're going to require end-of-line resistors, and you may find that you're going to have communications issues. So what my recommendation has been over the years has been a standard daisy chain with a doubly terminated network. So that means you have a terminating resistor at the beginning and you have a terminating resistor at the end. And if you do a daisy chain network, it gives us our most resilient bus, and it gives us our longest bus. You can put 4.5 spools of wire on a LON network. You can put up to 128 controllers on a LON network with the addition of a repeater at around 60. So it's a pretty resilient bus. The mechanism to communicate with these buses they come from our standpoint. Honeywell used for a long time exclusively LON. It didn't come out and using the backnet product or the backnet protocol until 2010, 2011, something like that. So the previous generation of LonWorks, Honeywell LonWorks controllers used a variety of different types of application-specific controllers and freely programmable controllers. These are some of the topographies that I just talked about. The loop down on the bottom right there. And you'll notice that it is a singly terminated topography. You can have a star network top right, And again, it's singly terminated. The daisy chain top left is singly terminated in this example. And you have a mixed where you have a loop and a star, or not a star, but a T-tap, as well as daisy chain. So that's the different types of of topographies that you can use with this thing. As I said, in my opinion, over 20 years of using the LON product, it's been the best practice would be the doubly terminated daisy chain. So if you buy cable, these are a number of the different types of supported cables. If you buy cable from Brody Precision, we're going to sell you this level 4 cable specification right here that's outlined in red. And again, you're looking at like 4.5 spools of wire on a network, which is pretty damn good as far as resiliency. And the cable itself is not that expensive. It is non-shielded. So what the level 4 cable specification gives us is a capacitance that is based upon the wraps of the twists of the pair. So a shield is not required. In fact, a shield would hinder it. It would create like an antenna effect. So because of the twists per foot, wraps per foot, a shield is not required. And again, it's not polarity sensitive either, so we don't have to worry about positive and negative and color coding. As I said, the level 4 cable specification that you see here is what you will typically get if you buy cable from Brody Precision. And this is what I meant when I was talking about the termination modules. We sell a Honeywell flavor of terminating module, and it comes, what's shown here on the bottom is with the brown and the orange terminator. That is the 2 wires that are used for the doubly terminated. If you were going to have a singly terminated network, you would use the yellow wire along with the brown. And that would be used more in a star or a T-tap or something, one of the other topographies. But this is what my experience has led me, this is going to be our most resilient network right here, is a doubly terminated daisy chain network segment. Now, we have basically with the Honeywell product line, we have the XL10s, which are basically phased out. I think they're still available. We can still purchase them for those networks that you do not need, if you just do a direct replacement or something like that. But the LON Spyder product is what Honeywell moved into after the XL10, and that started around 2007 with the first Spyder product that came out. And over the years, now that it's 2020, we have evolved to a very large, there's a number of different types of Spyders and model numbers that you can get that come essentially in the LON flavor, as well as BACnet. We're going to continue on the LON Spyder, but we'll talk briefly about the BACnet product as well. A lot of you probably know this already, but if this is a review, the part number of a Spyder has everything to do with its configuration. The P is going to be, it stands for programmable. And then the Spyder comes in 2 flavors. Essentially, at that point, it comes in a unitary or a VAV flavor. So it's going to be a PU or a PV. And then the third character is going to be your protocol, which is, in our case, it's going to be LON. So PVL would be programmable VAV controller, LONWorks communication. And then the next 4 characters are going to be the IO configuration, number of universal inputs, number of digital inputs, analog outputs, and digital outputs. Now, with the VAV types, they come in two flavors as well, with actuator and without actuator. So your non-actuated VAV controller will have an N there, and the actuated will have an A. They all are Sylk. Every single Spyder that is manufactured comes with a Sylk bus. It's a Honeywell proprietary communicating bus. Again, it's not polarity sensitive. And one of the reasons that I stress the level 4 communication cable is that we can use that for the Sylk bus as well. The unitary flavor of the Spyders has a relay type, which has hard 4 amp at 24 volts AC, real relays built in, and it has a number of commons that are available to those relays for multiple transformer applications. If you had a cooling transformer and a heating transformer, and you had maybe a third or a fan transformer, you could separate all those powers with the relay type Spyder. Whereas the standard Spyder, the one without the R, you basically do not have that option, and isolation relays would be required. The ILC, the individually licensed controller, is the non-branded flavor of Spyder that you can purchase and put on a, say, like a Vicon network or on a non-licensed Spyder licensed network. In order to download a Spyder, it has to be appropriately certificated and licensed. And if you do not have that option on certain JACEs, you would need to purchase an ILC Spyder. It's a little more expensive. It's non-branded, but it will get the job done. In the VAV controller, they come in the LON flavor. They come in 3 flavors, 3 essential model numbers. Again, you're looking at a programmable VAV, and the top that you see there is the 0000AS VAV controller. And I'd like to briefly discuss the beauty of that particular model. Now, you may be sitting there wondering, okay, what good is this particular model if I have no I/O available to us? A lot of cooling-only VAV applications or VVT applications only require an actuated damper motor with a space temperature sensor. So if I were to install a TR series Sylk wall module, and they come in a bunch of flavors as well. You have the TR40 series, you have the TR70 series, and now you have the TR120 series. That gets our price for a VAV cooling application very, very competitive with the rest of the industry. And the nice thing about this thing, unlike a lot of the other vendors, is it's completely programmable. I'm not suggesting that our contractors go out there and reinvent the wheel and come up with a VAV applications, because that's why God gave us the Venom apps. They work really well for VAV applications, and they need to be balanced, or if they are balanced, a third-party NEBS balancer is going to have to come in and do what he has to do to get the appropriate airflows, and for us to do our proper CFMs, that box has to be balanced correctly. So in order for him to interface with that, we're going to need to use something that he can talk to as well. So either you're creating a GUI application with a browser, or you're using rapid, balance, rapid balance, or you can use the TR series, 70 series wall module to do balancing for your balancer. So that top model number there, that PV000AS, very, very cost effective, very inexpensive, very competitive. Goes in quick. Now the next in line there is the 4022AS. So that's got 4 universal inputs, 2 digital outs, and 2 analog outs. That works great for if you have a electric reheat, or even if you have an SCR reheat, you have your 4 universal inputs, so you could use Sylk or a conventional wall module. You could use discharge air sensors. Whenever you have a heating coil, I always recommend having a leaving air sensor. So that particular controller would work out really well. And you'll notice that it doesn't, the 2 outputs that are required to operate the floating damper motor on the actuator are, they're not included in the part number, but they're basically when you buy an actuated Spyder, there are 2 that are dedicated for the floating damper motor. So they're not showing up in the part number. It's not a 4024, it's a 4022 because the 2 are dedicated. And then if you have an application where you need a lot more I/O, they make the 6436 AS. And again, you're missing 2 digital outputs which are dedicated for the actuator itself, the floating actuator. Power open, power close. All VAV controllers include the integrated pressure sensor, which is their flow bridge for velocity pressure. And everything that you see up here also comes in the backnet flavor. So you're essentially looking at 6, not including the ILC, because every single one of these models comes in the ILC as well. So there's a good variety of controller models to match your application and keep your price point down as low as possible. We also have 2 models without the actuator built in. Now, if anybody has seen what a Spyder looks like, it's about 7¼ inches wide. And if you add the floating Series 60 actuator on there, it gets to be fairly large. You know, you're looking at almost a foot in length. It's, you know, it's like between 10 and 11 inches in length with the actuator. Now, some of the retrofit jobs that we go on, it's not acceptable. That's too much. It's too big. We can't fit that direct coupled actuator on top of the shaft for the damper. So you may put the controller in, maybe mount it to the ductwork or in a separate location and wire the floating series actuator, Series 60 actuator back to this controller. And you'll notice now that you have a PV 4024 and a 6438 because the dedicated digital outputs are now back on board, or because the actuator is not included. And again, it has the integrated pressure sensor and also available in the ILC as well. Now, the other type of Spyder that is manufactured is the unitary type, and we use this particular model for just about everything else that doesn't require a flow bridge. Now, this is not to say that you can't use a VAV controller. It's fully programmable. You can put anything program-wise into a Spyder that you want to. If you wanted to use the flow bridge for very low differential pressure application, you could do that. I'm not a big fan of that. Don't recommend that. But the unitary controller, the one of the nice features of this particular controller is that it's has the extended temperature range. So that means that it can go in a rooftop unit, and it's good for, I believe it's -40 Fahrenheit to $140. So it can live outside in a rooftop unit. Not that it's not waterproof, but it can live in the temperature extremes of a rooftop unit or an environment that would not be suitable for the standard model. The 3 unitary flavors are PU, the 1012S, 4024S and the 6438S. The one particular unitary controller that's not showing up here is the Spyder Relay. That came out a little bit later. It has the dedicated onboard relays for the digital outputs rated at 4 amps DC, or AC rather. And that would have an SR on the end of it. And it has to be purchased for the 6438S. So you have the Spyder Relay flavor would be the PU6438SR. Now the Spyder Relay also has a more capacity in it for programming as well, and it is the only Spyder that you can use with the extended I/O modules, the Sylk I/O module. So if you're putting a Spyder on a job that exceeds the point count that you see on a 6438, you may add there are 3 flavors of Sylk I/O modules. You would have to use a Spyder Relay unitary controller for that. They don't make a Spyder Relay in VAV, so it only comes in the unitary. It comes in ILC, it comes in BACnet as well. I don't know, worth mentioning, back in 2007, when the Spyder first came out, it was one of the few controllers that was out, a twisted pair controller that was out on the market that had an onboard clock in it. Now, that is only significant if we need to know what time it is and if we know what the date and time is. For example, on a boiler plant, and I want to enable my boiler below, say, 40 degrees outside air. I don't really care what time it is. I don't care what the date is either. All I care is that it's cold out. Maybe that doesn't make a big difference. But if you're using a standalone Spyder, this is, without a chase or a schedule available to it, you have the ability to put an onboard schedule into a Spyder and it will tell time. Now, the access to that schedule would be through your TR75 wall module. And it's not the greatest, but it is a fairly inexpensive user interface to get to the schedule. We have our Johnson product that has a PCA controller, which does know what the time is. But in their infinite wisdom, Johnson did not give us access to the schedule through the user interface or the display. This is something that Honeywell has done since the inception of the controller. Nice feature to have, but a lot of contractors forget to set the time after they download and commission their controller. It's something that we can go over in a little. And another nice feature, which most controllers have, it has onboard DC power. It's, I think, only 250 milliamps. So you can put a pressure transmitter or some sort of DC power device wired directly to the Spyder without the addition of a DC power supply. That's kind of a nice feature. Now, in a standalone operation that is Spyder by itself without a network, we would have to connect to the Spyder somehow to give it its program, and that's done through the use of a station in Niagara 4. Normally, when I work on projects for contractors, I don't have the luxury of the network that the controller is going to live on, or sometimes for some of our other contractors, it is a standalone operation only. A lot of our contractors aren't as savvy as others, so they'll purchase like a job in a box type of deal where I need a programmable controller with an interface for the technician to modify set points, but it doesn't require graphics, it doesn't require a network, and there's nothing else it needs to talk to. For that, again, all Spyders have to start in the Niagara world as far as the programming is concerned. So we have to create a station, and we have to download our controller through that station. We have to download it through a network interface, and then what we usually plug into with our laptops is the Echelon. What's it? A TPFT10. It's the LON stick. A lot of our contractors that have been doing this stuff for a while, because of the LON interface that's required on a laptop, we have a limited capability. I think there's only one or two that Echelon provide that'll plug into a laptop that you purchase nowadays. It's a USB to LonWorks adapter. So we create a station inside of a Niagara environment that we make on our laptops, and we download to our controller through our LON stick. For those jobs that are getting full-blown networks and we're putting them on Jaces, we have, this is the Honeywell Jace with a LON expansion module to the right. And that would be for like a network job where you're going to have multiple controllers that are daisy chained or done through some sort of topography going back to a Jace, and you would download through your Jace network interface. And the network interface on a Jace represents as a LON card expansion module that's plugged in on the right here. One of the things that we see in the contractor world is very often a contractor will get onto a job that another contractor has installed, and they don't have the station that the Spyder program was created in. And the owner of the building has said, look, that contractor is no longer on the job anymore. We created this program for my air handler. I don't like the way it's operating. Contractor B enters the scene, doesn't have the program that the Spyder was created in, the station that it was created in. And a lot of times that can be a problem, because if you don't possess the station, what ability do you have to access that existing Spyder? You have all the tools. What you don't have is the software of the station that the program was created in. So I made a little demonstration of how that would happen if I was a contractor walking onto a job and connecting up to an existing Spyder that I did not have the station for. So I'm going to jump over into my N4 tool, and I am going to start up a station that I created up here, Tech Tuesday LON Spyder 1. And essentially all I did was create a station, give myself a password, and that's all that's created so far. So pretty quick, pretty easy to jump onto a LON network with your laptop or with the Jace that's already there. Now, if there's a Jace on the job already, presumably the program resides inside of the Jace that's living there. But if you do not have a Jace and it's a standalone Spyder, this next technique that I'm going to show you may be an option to affect change on an existing Spyder that you don't have a program for. So all I did was create a station, put some creds in. I'm going to log into my station at this point. And you'll notice that we have our standard driver's container that has the Niagara network and nothing more. That's all that's living in here at this point. You would probably be working from your laptop, but so you could bring a Jace out to the job and connect up to the Jace at you need a network interface of some sort. And by that, I mean the expansion module that comes on a Jace or the LON stick. You need some means of communicating between the N4 and the physical topography. That's called a network interface. At this point, in my driver's container, I would need to add a LON network. So I'm going to drop a LON network on my driver's container. Drop a LON network on my driver's container. And my tool now has a LON network built into it. Now, the default screen for the LON network is the device manager screen. Now, you'll notice the only thing that comes forward is the local LON device. And this is something that a lot of contractors forget to do on a J station. I'm working on a laptop. So on my test bench here, I have a Spyder, and I have a laptop and a LON stick interface, which is a USB-to-LonWorks interface. And that is represented by our local LON device. The LON stick represents the local LON device. Now, the one thing about a laptop using a LON stick is it's not required to commission the local LON device. But if you have a Jace and you have a LON expansion module, one of the things that contractors always forget to do is to commission the local LON device. Now, that only becomes necessary if you're starting to get into network changes that are required or that may be required. By that, I mean, I'm going to drop open another tab here. If you right-click and you go into the property sheet of the LON network, there's a number of slots that we have access to for the LON network itself. And most of the time, when we jump onto an existing LON network, and that could be an old XL5000 network, it could be a Distech, it could be any LON network that you're on. You may not know what your domain is. And out of the box, it comes in as a domain length of 0. Now, let me show you what I mean by that. You'll notice that my local LON device has a Neuron ID built into it. I have no ability to change that, by the way. Nobody does. You can't change the Neuron ID. It's built into the chip. So if I were to, say, walk onto an existing job that I didn't have the Spyder program for, and the owner wanted me to make changes to it because he didn't like the way the air handler or the piece of equipment was operating, I could jump on to a LON network using my laptop and a LON stick or a Jace and jump onto the LON network plugged into the existing devices. And first thing I would do is hit my Discover button. So I hit the LON Discover button and I got nothing. Nothing showed up in my Discover pane up at the top. Now, one of the nice things about LON networks is that most LON devices have service pins built into them. And this becomes particularly important when you have no earthly idea what domain that network lives on. I showed you on the property sheet where our little network wants to remain. Its domain ID has a domain length of 0. Okay, so what that's saying to us is we have a network neighborhood, a network domain based on a 0 domain length. So there's nothing significant there. If you notice, there's a multiple drop down here. You could have a domain length of 6 or 3 or 1 and create multiple domains on a single topography if you wanted to. So I'm going to jump back over here, and when we hit our Discover button, nothing came up. The nice thing, one of the nice things about LON networks and LON devices is the service pin. And often when I'm upgrading an XL5000 job and I have no idea what domain things live on, because this will be the first thing that I usually do is I jump on the network and I try to find out what devices that live out on the wire. One of the things that you have available to you with the LON driver is this thing called the LON Utilities Manager. And we use this for a lot of different things. It's a great troubleshooting tool. It is also something that can be used to identify problems with buses and identify domains and networks, for example. So if I change my drop down here to identify and I hit, instead of link, I hit my service pin and hit the execute button, it's basically waiting for me to hit the button on my device. And I think we have 5 minutes or something like that. It's built in to the driver. I'm going to hit the service pin on the Spyder that's living on my test bench here. And what it picked up was the neuron ID, the program ID, and also, more importantly, the domain ID. And what this is telling me, based on the information from hitting the button, is the controller was programmed on a network domain of length of 1 and an ID of 2C. So what that means is they made a length of 1 and an ID of 2C. Now, for anybody that's been working with the Honeywell product, this is the LON spec default. A lot of Honeywell controllers want to live in this on this domain length and ID. And the reason that they do that is though it's unique. It doesn't it doesn't discover with just any old with any old discover feature. Now, when I hit the service pin, it shows up on my utility manager, but it also showed up on my device manager. And it's telling me that, okay, I did find a Honeywell device out there with a program ID and a neuron. And it's saying to me that we already know that it lives on a domain of a domain length of 1 and an address of 2C. So what I could do at this point is add it to my network. And here you have the ability to name things, but you'll notice that it's just bringing it in as an XL10 next generation. It doesn't know really which Spyder flavor of all those models that we changed, that we went through in the beginning through our slide deck. It doesn't really know anything about that. So I'm just going to bring it in. Now, as I said, when we first dropped our LON network out onto our station, it's at domain length of 0. So the Spyder that it discovered is on a domain length of 1 and an address of 2C. So in order to effectively communicate with this device, I either have to change my network to domain length 1, 2C, or change the Spyder to the domain that I'm on, which is a 0 length. So I would change it at this point to what is in my station, because now I own the Spyder, and I will hit the commission button. So now I'm changing the network address. I'm not changing the subnet, the node, or the channel, but I am changing the domain that it lives on. And as our commission bar across the top of the screen scrolls across, gives us an idea of where we're at. Hopefully it goes through with success and not a failure, which tells me that my 2 foot of LON network is not compromised in any way. So now I can tell you that this Spyder is living on the same domain as my station is living on, or my LON driver, which is a zero-length domain. Now, the other thing that I mentioned is that the tool, the driver, doesn't know what flavor of Spyder this is. And we just covered, a significant different, number of LON Spyders that can live on a particular bus. So what I would do at this point is I know where my Spyder is because I hit the service pin on it. I could also find out at that point the model number of the Spyder that it is by either looking at the IO or the tag that's on the side of the Spyder. I happen to know that this Spyder is a Spyder relay. So the default screen is the summary view for the controller if you double click on the added network device. And here I would change it to a Spyder relay because that's the particular flavor of Spyder that I just discovered. Hit my save, now my database matches. And you'll notice now I can do something called a learn logic. And that's sort of, in the old Spyder tool, it was called an upload. Now they've changed it to something called a learn logic. And it's going to give me a caution. It's going to say, hey, if you have a database item that's already open, it's going to blow it out. You want to continue? And my answer is yes, because I got nothing. We just walked onto this network. And the next thing it wants to do is say, hey, you have a Spyder library. Do you want me to see if it matches any of the different models that you have in your library? And my answer to this is no. So now it's going out on the wire and it's telling the Spyder everything that you have in your program database, I want in my station. So the information is going between the Spyder now and my Niagara station. While this is happening, does anybody have any questions so far? I've been sort of like rolling through this. Okay. And it is now telling us that I'm not sure why our tool doesn't say that our learn is a success. That whole line disappeared from our job. But if now I can double click on my control program and this is what it pulled out of the controller. Now, I'm going to zoom out a little bit here and you can kind of see that it brought in all the function blocks. It brought in all of the different IO that is included in this particular Spyder. And you'll notice now I can also right click on the LON Spyder and go to my termination or my terminal assignment view. And I can find out everything that was wired to the inputs and the outputs. Kevin had a question. Popped up and went away. Matt, did you see the question come up?
You send it directly to you. Maybe unmuted to ask the question.
That's another idea. It came up and it disappeared, so I'm not sure where it went.
My question was, does the USB sticks only work on the 32-bit version of Workbench?
I didn't understand. Say that again, please.
Kevin, yes, the USB LON stick will only work with a 32-bit install of Workbench.
Yes. Okay, yes. Didn't hear that.
So if you have any intentions of doing direct work on the LON bus from your laptop, you're going to want to make sure that it's the 32-bit version that's installed. Echelon never came out with a 64-bit version of their software to be able to work with 64-bit version of Workbench.
Okay, now, this is what happened with the wire sheet. So we have a bunch of function blocks that basically are labeled function block 0 through function block, I don't know, 20 something, 24, 25. Also, what came through, Sam has a question also. You want to unmute, Sam?
Good point, Sam.
Which was what? I'm sorry.
Sylk IO, and you cannot learn the logic. So if you have a standalone plant with Sylk IO, you might be kind of stuck.
Correct. Way ahead of me.
Throwing that out there. We ran into it, so that's one of those kind of gotchas that I don't know if there was ever something that came out where you can do that.
No, there hasn't.
Nope. It's the long story short is I was trying to get to the point where I was showing you this is somewhat useful, this upload or this learn logic, but in my opinion, it's more trouble than it's worth.
Absolutely. But yeah, like you said, if you come up to a job that's standalone, doesn't have a Jace or anything, and the other contractor left, this is kind of what you're forced to do, I guess, right?
You can get certain pieces of information like your IO assignment on your base Spyder, but
the naming for your IO remains intact. That's about it. So at least you could start there and wipe everything else out in between and build it again if need be.
And that's where I was going to go to this. It's only partially helpful, in my opinion. And you spend more time trying to reverse engineer. I would just get the IO and start from scratch, because then I own it and I am familiar with the program and I don't have to mess around with somebody else's logic. But this is what it looks like when it comes through. It's a bunch of function blocks and a bunch of nubs, and you're looking around to see what's connected to what, and you can spend a fair amount of time. Now, it will tell you some of your network variables, and it'll tell you your IO, but it's somewhat, in my opinion, I've spent a while trying to back engineer what someone else has done, and it's just, I find it easier to start from scratch because I'm familiar with the tool and I'm quick enough that I can just start over. But if you are limited in your experience, this may be, the only option that you have. That was what I wanted to cover with the learn logic. Somebody had asked us to go over the upload and the download of the program. And you'll notice now also it changed our LNML file to the Spyder relay because we changed its configuration. We double clicked and we changed it here. But it came in as a standard unitary Spyder. And if I tried to do an upload, it would have yelled at me and said it's the wrong model number. So while you're hitting service pins, it's not a bad idea to figure out what kind of model number you have as well. I also am a big believer in the utilizing the Spyder library. I have found in my experience over the years that air handlers themselves, you may have heat pumps that are typical of, 15 or 20 on a floor, and you can duplicate a lot of things that way. But air handlers, I have found, are always a little bit different. They're depending on from job to job to job. You have chilled water or DX, or you have different combinations of electric heat or no heat or modulating heat. And so what I normally do is I build pieces of air handlers together and store it in my Spyder library. Now, I'm not sure if folks are using their Spyder library, but I think it's a best practice worth going into. It allows for predefined program applications to be built on a wire sheet. There's all sorts of different configurations for air handlers and rooftop units. And what I normally do is I'll do pieces of an air handler if it applies to my application. And I'll pull that from my Spyder library. You can either drop an entire device into your library, or just a select application from that program into your Spyder library. You also have S-Bus wall module configurations that you can put in your Spyder library as well. For me, at Brody, sometimes we get asked to work on a program for a contractor, and what I'll do is I'll create it completely on my local machine, save it to my library, and then send him or the contractor that library item to be installed in their library, and then they can just drop it out on their network. Very often, contractors are working on a station concurrently, or it's an existing station, and it's easier just to add a Spyder to your library and drop it out onto your either backend or LON network than it is to try and work from the same station that they're working from on the job site. So thereby, the Spyder library has come in very, very handy. This is typically what your Spyder library will look like. You have a device container, an applications container, and an S-Bus wall module container in all Spyder libraries that are created. Those three containers come in any Spyder library. Now, let me see if I go over to my taskbar and bring up my station. This was our discovered LON Spyder that we walked on the job. Went over this. A lot of function blocks, not really clear on what the heck it is. So I'm going to blow this guy away, because the problem with any kind of LON network is if I were to, the database now contains a neuron ID that's associated with this device. So I can do two things. If I wanted to create a new LON device on this particular network, normally it's much easier just to delete this guy. But you could also go into his property sheet, and under the device data, you're going to see the neuron ID. It's here that we can eliminate the database neuron ID for that Spyder. Okay? But for this particular application, I'm going to find that it's easiest just to delete it. Because what I'm going to do now, because if you remember, the first thing that we did was we commissioned him. So now this Spyder that I discovered is living on the same domain that my laptop and my LON stick is living on. So I don't want to use this. I don't want to use this programming for this particular, this contractor that we discovered with the function blocks. I'm just going to delete them. And what I can do is I can now go up to my sidebars and open up my Spyder library. And under devices, I created this thing called a rooftop unit. And I can drop him out onto my LON network. It's something that I already had created, already programmed. And what I can now do is discover, and this time when I hit the discover button, it should find what it previously found. And if you notice, it says it's on the subnet of 1, it's on the domain of 8, which was what it was previously done. But the good news now is that it did discover because we commissioned it. So now I could match by highlighting the discovered with the database item. And under the match button, I have the ability to select either the database subnet node, or I could use the discovered subnet node. I'm just going to leave it alone and match them up. I'm going to leave the name, but here you have the ability to change the channel, the subnet, and the node. And one of the best practices is, now that I've discovered him, I have also changed the subnet and the node from 1. The node is now number 1, not 8. So I would have to commission him. We already know that it is a Spyder relay, so our NML file is correct. But if we tried to download it with the wrong configuration, it would yell at us. And one of the other things that Honeywell does with its devices is, if you notice up here in the top left, it has a red arrow pointing down, and what that's telling us is that it hasn't been downloaded. It needs to be downloaded. There are changes in the database that don't match what's in the controller. Now, in order to effectively look at our program, we need to go into our engineering mode. And for most guys that are playing around with Spyders, they know a lot about how to get into the programming of a Spyder, and they know how some of the best practices or some of the different tools that they work with to make their jobs a lot easier and to streamline their process. But this rooftop unit that I created was something I pulled out of my palette. It's something that was created in the past. It's already been tested. It already works. All I got to do is download this thing at this point. And that was something that we were asked to go over. So what I've done now is I pulled an object out of my Spyder library. I've dropped it onto my LON network. I've commissioned him. And now the last thing that's is for the download to happen. So I could simply go to the Spyder download. Gives you two options. It gives you a full download or a parameter only. Doesn't even allow me to click on the parameter only because this thing's never been downloaded. Throws you a Spyder download. It's going to overwrite any changes to the database. It recommends a sync from field device. I don't really particularly care, so I'm going to hit yes. And while this is happening, it's going to take a few minutes to download this. At least 30 seconds, 30 to 90 seconds, someplace in there, depending on how big your program is. And what's happening now is the station that we created, on this wire sheet now is being transferred from our Niagara network and Niagara station now going into the Spyder. Now, worth talking about while we're waiting, and you'll see that our red light up here is on because we're in download. So it's telling us we really can't do much right now, but worth talking about is when we have our wire sheet information, the area that we create our program in, that's really an environment for us as a user. That's not what's going into the Spyder, obviously. You know, a bunch of ones and zeros or some sort of machine language. And you see here our download is completed. And we know that now because we have the two arrows that are living in there and not the red arrow. But this wire sheet view is the actual program as we created it and a user interface type access to that program. So when a program is, when you don't have the station for a Spyder, you don't have this wire sheet view. For any of you who are working on Spyders, if you look down into your files container, you're going to see a virtual XL10 directory. And this is where the wire sheets are stored. So if your wire sheet is not in your station, it's not going to show up in your virtual XL10 directory. Now I have two. One of them is that thing that we discovered, which is this guy. And you'll notice there's nothing in there. There's no real information in there. When I dropped out of my Spyder library, it put this thing in there. And you'll notice it looks exactly the same. The wire sheet view looks like what's in our control program because it is. It's exactly the same. So this wire sheet view is really the graphical user interface for the programmer. And I often stick things like, you know, text blocks to remind me how things have been configured, maybe a piece of information that will help out the next guy that's looking at the wire sheet. Because again, if we're downloading a Spyder, very often it's living on a network that has it's living on a network that has a JSON. So this virtual XL10 is going to live within the J station as it's living on my laptop. Does anybody have any questions about this? These virtual XL10 directories, a lot of times contractors will, because they're playing around with different stations, there may be different technicians working on the same station, working from one laptop or another laptop, and sometimes things are not appropriately stored on the JSON. You'll go to open up the wire sheet view of a device that's sitting on a network, and you'll go into the wire sheet view and there'll be nothing there. And normally what that means is that the tool, the database, the virtual XL10 file is missing or it's not located correctly on the station. So when you go into your engineering view on a Spyder and nothing shows up on your wire sheet, that means your station can't find the virtual XL10 directory, or there's nothing in the Spyder. Anybody got questions? Because it's kind of like 9:10-ish, so I don't know if you want to keep going or if I should like take questions at this point. Something else worth noting, unlike the backnet network, we don't have the ability in our proxies. LON networks handle variables differently than backnet networks. This may be a review for some, but for those of you who are not familiar, if we were to right click under actions, there's this thing called generate NVs. In the BACnet Spyder, it's called generate network objects. Okay, in the LON world, they're called network variables. So if I were to generate network variables, I could now go to my points container for my station, and I'm going to see a full list of network variables that I created on my wire sheet. These network variables are represented by these particular icons. A configuration variable, network input variable, network output variables. In my programming, normally I keep them on the right, and they'll say network output. Input variables I usually keep on the left. My logic typically goes from left to right, top to bottom. That's just the way I do it. It's my best practice. And a lot of times what I will do is I'll line up my objects in rows so it's easy to follow the data. I'm not a contractor, but I often do programming for contractors. So my work has to be reviewed by someone else normally. So I make it as easy as possible to follow logic. And by doing that, I don't just drop objects out onto a wire sheet. I give it some sort of logical order so that folks can follow it. And when people buy stuff from us, engineering services from us, they can basically save this to their own library and use parts and pieces of the different of the different parts of the program. For example, your setup setback routine, okay, your night setback or your night setup routine. Well, there's the block, okay. That application can be stored in your own Spyder library. Save to library, okay, and that would go in your own Spyder library. If you wanted to create a particular custom application that maybe you'll use again, maybe you won't, but you don't want to have to reinvent the wheel. I wanted to go over quickly. These applications that are in the utilities folder of your LON Spyder tool, if I drop out a application block, it's basically a wire sheet. One of the questions I get asked a lot is, what's the difference between a macro and an application? Because if I drop a macro out there, it has a different look to it. But if you double click and go into a macro, it looks like a blank wire sheet. Go up a level, go back into my application, it's a blank wire sheet. It kind of looks the same, right? So what's the difference? Well, the difference is a macro, I can't put certain variables inside of that. If I put in a physical point inside of a macro, it'll yell at me. Whereas an application, it's basically another wire sheet. I don't use macros a lot. If I use them, I'll use them for very, very specific pieces of information. And macros, I usually stick inside applications because they're limited in what I can do with them. There's certain network variables and certain I/O characteristics that do not go inside of macros. It just won't allow it. But you can do certain little bits of logic that would work, and then maybe that could fit inside of another piece of program. One of the other things that I cover, so I heard there was another question that came in. Dan, you want to unmute yourself and ask?
His question is, I've heard that the IF LON can be used with a 64-bit workbench. Can anyone confirm this is true? I've heard somebody else before say that it can be used with your laptop. I have not heard that it can be used with 64-bit. So I cannot confirm that myself.
Nor can I. An IF-LON is what? Now, that is a...
I believe that's the one that you use with the CIPer 50.
Okay.
I'll take note of that, and we'll look into it and get back to everybody.
Thank you, Dan.
I actually got to discover in the LON utilities in the control panel, but I haven't used it on the station yet. But I'm only running 32-bit on my machine.
I would tend to believe that it's not going to be able to. We'll see if we can get a hold of one to do some testing, and I'll see if I can find any literature on it. But the fact that I'm not aware of Echelon coming out with any new software that would allow that to happen. It's not really the adapter itself that's the issue. It's the software behind it.
Okay. You notice that on this wire sheet view, I dropped these two objects out here on my wire sheet, and now it wants to be downloaded again. Worth noting that, go back up into my slide deck. Let's see here. One of the things I wanted to talk about, with LON, we don't have the ability like we do with BACnet to do overrides. They make it cumbersome. There are certain things that are built into the points container. You'll see manual mode, and there's some variables that you can pull out of the system variables that come with that device for doing overrides. Normally, the point that I was trying to make is that I create through the use of select blocks and a network variable. You'll see on the screen here overrides that are built into my control program. And again, this can be something that you add from your library. Some guys do or don't, create that type of logic. I think it's just, it's a little bit of extra work, but it's worthwhile for the end user or for the technician that's starting up this stuff for the ability to override stuff. Overrides they can get you in trouble, like if you give end users overrides, a lot of times, they won't manipulate a set point. They'll just go right to an override. So overrides get us in trouble because it basically takes us out of automatic operation. But they're extremely useful when you're doing commissioning and testing and some other things that might be required. So the point of the deck, this slide that I'm showing here, is that I use an input variable that's connected up to a select block, and the select block creates the logic for my supply fan here. And what the other point that I was trying to make is that when I create overrides, I also keep them downstream of any safety logic that I might have. For example, if I have an override for a fan, I want to put that upstream of my freestat logic so that if my freestat trips for whatever reason, it still shuts my fan down. Okay? Just something quick worth bringing up. I don't know. That's kind of all I wanted to go into at this point. I mean, we could spend an awful lot of time talking about the different aspects of a Spyder program and some of the things that are necessary to build. We have individual courses that we teach for rooftop units and for VAV units, and we could get into a lot of different rabbit holes if we start talking of individual programming. But I just wanted to go over today the ability for uploading and downloading to some of the LON trunk best practices that we use, general overview of the Spyder operation, brief use of the Spyder tool, and I think I talked a little bit about some of the different points that are required for the Spyder operation. So if there are any other questions, now's a good time, bring them up. Okay. Anyone? Anyone? Bueller? Okay, so I'm gonna stop recording. That's gonna stop recording actually.